Hi, I'm Doyle Bishop with Tulsa Heaters Midstream. On this channel, you can expect to hear about all things related to process heating, but sometimes the topics aren't technical, but most of the time they are, so thanks for joining. So let's talk about turn down in a heater, and what does that mean, turn down? Okay, if you think of ratios, maybe someone says 4 to 1, turn down. I'm just going to put TD for short for turn down. What does that mean? Okay, well, in heating, there's an amount of heat that you're transferring to the fluid. That's called absorbed heat. And so let's pretend for a second that we have a heater that's 40 million BTUs per hour. That's how much heat is transferred to the fluid. That's the absorbed heat. That's the maximum. That's what the heater is designed for. If someone says, hey, can that heater run at 4 to 1 turn down? So you're probably pretty good at math. So you'd say, that must mean that we're going to transfer 10 million BTUs per hour. And you would be right. It's exactly what that means. That's turned down 4 to 1. 40 million to 10 million is the turn down. So another question is what is the limit? Is there a limit? Can I turn a heater down 100 to 1? Maybe you have a process that requires big turn down, and so you're saying, gosh, 4 to 1 doesn't get it for me. I really need 10 to 1. So is there a practical limit? There is. So let's think about two things. One, let's talk about a burner, right? The burner is actually providing the heat. It's like the engine of the car. It's providing the heat. So if I have a flame and I start backing the fuel gas down on that flame gets smaller and smaller. At some point, that burner won't be stable. It just simply blows out. Typically, a burner turn down, a reasonable burner turn down, is in the range of 5 to 1. That's for a burner. If you go significantly lower, you may have a stability problem with the burner. There are burner types that can go lower, but there's also another detail in there. And with that, I'm going to draw a heater to help explain that. So if I have a heater, a burner, as I turn this fuel down to this burner, this is a valve. As I turn this fuel down, guess what? It gets cold in here. So I may have a little bitty tiny flame, but it's really cold. And cold is a relative term. Let's say it's 800 degrees. Maybe you think that's not very cold, that seems really hot to me. Well, at 800 degrees, the problem is I don't burn the carbon monoxide in that environment. Well, if I don't burn the carbon monoxide, where does it go? Well, it goes out the stack. So yes, my burner's stable. Yes, I have a flame. Yes, it's not unsafe, but now I have an emissions problem of a lot of CO. And so maybe you have an environmental permit. Maybe you have a safety concern. So you have to be cognizant about turn down in a cold environment. Now, you also need to know that it's fairly frequent to experience this during startup because you're bringing it up slow, but it's a transient condition. You get through it fast enough, and once you get to around, let's say, 1200 degrees in here, now suddenly that's hot enough to burn this CO, and it goes away. Okay, so that's a burner. What about the coil itself? Am I worried about what happens in the coil? Now here I'm going to draw a more simplified heater. This is not really kind of how they look like, but we're just going to draw it this way. So let's say I have a coil, and it comes in like this, and then it goes out like this. Okay? This is my fluid. This is what I'm heating. This is called a single pass or one pass, meaning there's only one pipe that's carrying this fluid. Now, sometimes I have a higher flow here and a lower temperature change, and it requires a different setup. Well, that setup is called a multi-pass, and it looks something like this. Comes in like this. And then I have a pass like this. So each pipe is its own pass. So my fluid comes in here and it comes out here. This is called a 3-pass. Well, if I don't have enough flow of fluid going through this, then I'll have maldistribution. One of these passes is going to kind of run dry because symmetry is not perfect. And so I don't get perfectly even flow through each pass. So when I have a multi-pass furnace, I have to be worried about the turn down of the fluid. Typically, the fluid turn down, when it's a multi-pass, this is a 3-pass, the turn down is in the range of about 3 to 1 is the maximum turn down when you have a multi-pass furnace. So maybe you're asking, what about a single pass? Well, single pass, I'm not worried about maldistribution because all the fluid that comes in one end of the pipe goes out the other. I'm not worried about maldistribution. But when it's multi-pass like this, if this coil runs low or runs dry, I can overheat it and damage it. So I need higher flow, higher pressure drop to force good distribution, even distribution through the heater. So, in summary, what did we say? A burner is probably good 5 to 1, and then the fluid, if it's a multi-pass, is around 3 to 1. Okay? So, I think that's about everything that you need to know about Turndown.
Hey, thanks for joining. If you enjoyed this episode, hit like or subscribe to get more information about process heating and Tulsa Heaters Midstream.